Remember from Algebra 1 that the two rules of solving equations are the addition rule and the multiplication or division rule. These rules are extension of the additive property of equality and the multiplicative property of equality. These rules apply to both true equations and false equations. So let's have a true equation here. So this is a true equation. Since we all know that 4 plus 3 is 7, and we have a false equation. Let's have 4 plus 3 is equal to 5. This is a false equation because we all know that 4 plus 3 doesn't equal to 5. So we can add the same number to both sides of an equation without changing the truth or falsity of the equation. So we can demonstrate this by adding negative 5 on the both of the equations, which we're gonna add them on the right side and on the left side. So let's move this actually so we have a space. Let's put plus, and this also plus negative 5. Now let's add. So we have 4 plus 3 is 7, minus 5 is 2. Then we have 7 plus negative 5, or just 7 minus 5, that will be also 2. So this is the true equation, by the way. And now here we have 4 plus 3. 4 plus 3 is 7. 7 minus 5, since addition and subtraction will multiply, will give you multiplication. So 7 minus 5 is 2, and 5 plus negative 5 is 0. So as you can see, the equation is still false. We can use the additive property of equality to prove that the same number can be added to both sides of an equation without changing the solution or set of the equation. So, for example, we have here x plus 2 is equal to 6. Now let's solve for x first. So we're going to move it to the other side, which has 6, which the sign will change, will become negative 2, and 6 times negative 2 is 4. So 4 is the answer for x. Now, let's change it a little bit. Let's add both numbers on the equation. Let's add the same number, negative 5, so that we can prove that it's still the same. And the value of the equation doesn't change. We have x plus 2, x, so we have x here, and 2 minus 5 is negative 3. Then we have here 6. 6 minus 5 is 1. Now we can change x to 4, which is this one. Make it 4. 4 minus 3 will become 1. So 4 minus 3 is 1. So we didn't change the value of the equation all this time. So equations that have same solution sets are called equivalent equations. So this means x plus 2 is equal to 6, and this one, x minus 3 is equal to 1 is an example of equivalent equations, or the new equation and the original equation are the equivalent equations. So this is the old equation and this is the new equation since we added 5 on both sides. So a similar explanation could be used for the multiplication or division rule. We will forgo this explanation and state the two rules as follows. So we have the addition rules. We have the addition rule of 4 equations. The same quantity can be added to both sides of an equation without changing the solution set of the equation. For the multiplication or division rule of 4 equations, every term on both sides of an equation can be multiplied or divided by the same non-zero quantity without changing the solution set of the equation. So here, we remember that we always use the addition rule before we use the multiplication or division rule. This is because the solution of an equation undoes a normal order of operation problem. To demonstrate, let's begin this by having this. We will begin with 4. Now let's multiply 3 to 4. Then we're gonna add -2. So this will give us 3 plus 4 is 12 minus 2 is 10. Now, to undo what we have done and get back to 4, so we need to get this. So we must undo the addition of -2 first and then undo the multiplication. So to demonstrate this procedure, let's replace 4 with x. There we go. So now let's solve to find that x is equal to 4. We all know that since okay, so let's solve for if x is really equal to 4. First, we need to add first before multiplying. So we need to add +2 and +2 to this side. That will give us, this will cancel, and on the left side we have 3x left. And here 10 plus 2 is 12. Now let's multiply 3 by both sides. So the 3 will cancel, giving us x is equal to 12 divided by 3, so that is 4. So as you can see, we proved that x really equals 4. So we remember from Algebra 1 that the 5 steps of solving simple equations with one variable are: eliminate the parentheses, add like terms on both sides, eliminate the variable on one side or the other, then you eliminate the constant term on the side with a variable and eliminate the coefficient of the variable. Now, let's use the steps I said in this example. Okay, so as the first step, we need to eliminate the parentheses first, remembering that if the parentheses are preceded with a minus sign, we must change all the signs, like for this example here. To eliminate this, we have a negative sign here. Since this is a positive one, it will become negative 2x. And here, we have a negative and a negative, since we know that a negative number times a negative number will equal to a positive number. That will become positive 5. Actually, I take that back. Only on this part, of the equation. So that will stay the same as -5. Then here we have the plus sign. Let's just remove the parentheses since it's just a plus sign. Actually, this is a minus. It's actually subtraction. Now, let's add the like terms on both sides. So we must simplify. Since we have coefficient 12 and 5 there, 12 minus 5, 7. 7 minus 2x. Here we have -2. -2 and +3. And -2 plus -3 will give us -5. Now, let's move this 2x to the other side. So we're gonna have add 2x so that we can cancel this. But if we add 2x on this side, we need to also add 2x on this side as well. So that gives us 7, and here we have 3x minus 5. Now let's move -5 to the other side so that we have 3x left on this side. So I have +5. That will give us 7 plus 5 is 12, and what's left here is 3x. So this will cancel. Okay, so let's find 12 plus 3x. So let's multiply both sides by 3 so that we can get x. So what's left is x. 12 divided by 3 is 4. So this is your final answer. 4 is equal to x.